All right, continuing on today's topics. So functionings that agree at all but one point. So let C be any real number and let f of x equals to g of x for all x not equal to c in the open interval containing c. Then the limit as x approaches c of f of x is equal to the limit as x approaches c of g of x. All right. So if in this case, what means, this is what we call a hole that you can fill in a graph. So for example, on the first one right here, let's look at example 5. So find the limit as x approaches -3 of x squared plus x minus 6 over x plus 3. So if I do direct substitution here, I'm going to get -3 squared plus -3 minus 6 divided by -3 plus 4. I'm sorry, plus 3. So if you guys notice here, what ends up happening is that I have a 0 in the denominator. On top, I don't have any problems, right? Well, actually, I do. I get 0 over 0. And this is what we call the indeterminate form, all right? So this is indeterminate. All right. When you guys have a number over 0, that is called undefined. This one is 0 over 0, so this is called an indeterminate form. So these graphs, if you guys were to graph this, you would pretty much notice like it's a parabola if you try to graph it on Desmos. And then as you approach -3, you're going to see that if you try clicking on -3, you're going to have a hole in the graph. It still looks like a parabola. So this is what we call a removable discontinuity. All right. So that means that we can determine pretty much what the limit is as x approaches -3 of x squared plus x minus 6 over x plus 3. So here, what we have to do is pretty much determine what's the other way, right? We want to find a function that approaches the same value and still has a limit. So here, if you notice, we can factor the numerator. If you guys remember how to factor, use the big X to factor. What two numbers you multiply to get -6, and when you add them, you get +1. So that would be x plus 3 and x minus 2 divided by x plus 3. So now this is where I'm finding g of x, right? So I simplify. I can divide these two out, and I'm looking now at the limit as x approaches -3 of x minus 2. Now, knowing this information, I can now use direct substitution. One more time. So here, this is -3 minus 2 equals -5. All right, so that means that pretty much if we look at this graph, we can say that this is approaching -5. All right. So our value here would be on the graph, the undefined value would be like -3 comma -5. So it's just an extra step. You guys have to do some algebra here to be able to determine it. All right, so let's look at example 6 now. So we want to find the limit as x approaches 1 of x cubed minus 1 over x minus 1. So again, here, if we do try direct substitution, you'll notice that we have 1 cubed minus 1 over 1 minus 1, which is again 0 over 0. So again, we get an indeterminate form. So let's try to factor this. And now if you guys remember, part of the diagnostic assessment was pretty much whether or not you guys can find the sum and or difference of cubes. And this is where we're going to start to apply those. So we're looking at the limit as x approaches 1. This is a difference of cubes. So that's going to be x minus 1 times x squared plus x plus 1. If you still need assistance on how to factor those, let me know and I'll help you guys out. All right, just let me know. And then everything divided by x minus 1. And again, if you guys notice, there's a couple of things that are already divided out, right? So there's already x minus 1 being divided out right there. So this is equal to the limits as x approaches 1 of x squared plus x plus 1. And then again, if you plug in 1, now you get a 1 squared plus 1 plus 1, which is equal to 3. All right, now let's look at example 7. So the conjugate problem. So some of you guys may heard of the conjugates. is pretty much is like multiplying the difference of two squares. So we're looking now at find the limit as x approaches 0. So again, if you guys plug in 0 here, we end up with a 0 over 0, right? 0 plus 1, square root of that is 1. Minus 1, you get 0, and then divided by 0. So we want to make sure that we can determine what value of x is this graph approaching, because I'm pretty sure it's approaching some number, but I want to make sure that I can find it algebraically, right? You can use the graph to check it out, and then you guys may be able to find it that way. So here we're going to be multiplying by the conjugate. So the conjugate of the numerator, the only thing that's changing is the negative sign right there. So this is going to be x square root of x plus 1, and then plus 1 on the outside, and then same thing, x square root of x plus 1 plus 1. So if you guys take note here, this right here is just equal to 1. So I'm just changing the appearance of the fraction. I'm not actually changing the values itself, right? So if we continue forward, the nice thing about this is that when I multiply these two, it becomes like a perfect square, right? So that's going to be the square root of x plus 1 quantity squared. And then negative 1 plus 1, right? Negative 1, it's a difference of two squares, right? And then divided by, if you guys notice right here, we're going to have x times the square root of x plus 1, and then plus 1 one more time. So again, I'm sorry, I forgot to put the limit part. Don't ever forget to put the limit part. The limit as x approaches 0. So now that I want to simplify one more time here, so if I square these two, I get the limit as x approaches 0 of x plus 1, and then minus 1 divided by x times the square root of x plus 1 plus 1. And again, if I simplify a little bit further here, this is 0, and then these divide out, so I'm left with 1 over the square root of x plus 1 plus 1. And again, I forgot to put the limit. So the limit as x approaches 0. And again, if you guys plug it in here now, so we're going to get 1 over the square root of 0 plus 1 plus 1. And this is just equal to positive 1/2. All right. So on the next one, example 8, we want to find the limit as x approaches 0. And this is called the fraction action problem. So pretty much what you guys always want to do, if you see a fraction either on the numerator or denominator, the first thing you want to do is actually make it a single fraction. So now we're looking at the limit again as x approaches 0. So the lowest common denominator between these two would be just 3 times x plus 3. And then cross multiply, that's going to be 3. And then minus 3, right? Minus x plus 3, I'm sorry. Cross multiply over here. And then divided by x. Now, the reason I'm doing it this way is because I want to make sure that you guys remember some of your previous training from middle school, right? The keep, change, flip. So keep, change, flip. And if you guys remember how that goes, so we're looking at the limit as x approaches 0, right? We're going to keep the first fraction the same. So that's going to be 3 minus x, and then minus 3 one more time, divided by 3 times x plus 3. And then change the sign. So I just simplify the first part, change the sign for the second part, and then flip this one, so 1 over x. And then again, take it forward. So we're looking at the limit as x approaches 0. 3 minus 3 is 0, so it's negative x divided by 3 times x plus 3, right? Combine these two. This goes away with that, and now you're looking at the limit as x approaches 0 of negative 1 over 3 times 3 times x plus 3. Do your direct substitution, and we end up with negative 1/9.